And so I look at this problem as a complex systems problem, like a health problem. We have one patient. Patient is planet Earth. Our state of medicine is about 18th, 19th century, and we're in pretty critical condition. And so we have a complex systems problem, and coming from IT infrastructure again, what we need is data on the various layers of the system. We need good, much better tools than we have for analyzing that data and looking at the system in a variety of different types of ways. The good news is we have technologies that we have not applied to this problem yet that exist for other things. So the disruptions in remote sensing, drones, surface, aerial, space, most of that stuff has not been applied to this problem at all. And likewise, with computing and models and analytics, so I worked on a project with ocean climate risk that was taking approaches to studying complex systems in finance and IT and applying them to study ocean climate risk. So one of the ways I look at this is that the full weight and force of what the tech industry knows how to do has not been applied to the problem of understanding the climate system. That's good news, because that's low-hanging fruit. So we could understand the system a lot better and a lot faster. And if we want to intervene in the system, I would argue that we have to. And I've talked to politicians and people on the left and the right. And what I tell them is that if you're interested in intervening in the climate system, we have to understand it much better than we do today. And we have to make investments in the scientists, the platforms, and the capabilities that we need to understand the Earth system better. It's a prerequisite for any intervention that we do. So that's part of the whole deal here. And in order to do that, we have the mother of all interdisciplinary problems. And so I don't know if you can read this chart, but the disciplines involved go from nanoscale particle generation through localized weather systems all the way up to global climate, data and information systems, civil and environmental risk and control systems, all the way into human and societal operations and the way we make decisions together as a human population. So that's a tricky one, and I'm going to argue that we need to do all of the studying that we need to do in the next decade because of the timelines that I pointed out earlier in the conversation. So for me, the question is, how can we coordinate an agenda to learn what we need to know about possible options for protecting ourselves from heat risk in the context of the kind of damages that we might be looking at, even if they're only possibilities by the middle of the century. And so to that end, there are some different kinds of exploration that we need to do, technologies we need to develop. The aerosol generation, I'll share with you guys, and I'll talk a little bit more about the fact that there really aren't research programs today. There are no formal sources of funding in this area. And to my knowledge, the only place in the world where they're developing aerosol technologies to try to perform these techniques and understand them is here in Silicon Valley. And it's a team that's comprised of a half a dozen retired engineers, some of whom co-invented inkjet printing and the optical mouse. And they've been working on this problem for 6 years for their grandchildren without pay. Now that work is likely to move into a more formalized setting where we can work more actively on different approaches and different ways to scale it up. But the technology is critical to understanding what might be possible and what we're going to feed into our models and analytics. And so alongside the technology for dispersion, we need lots of improvements to our climate models and analytics, and we need specific models and analytics that look at these specific types of approaches. And I could talk to you a lot about some of the limitations of models and our reliance on them to make decisions about climate. For any of you who've worked on complex systems, you know that a big part of the challenge is looking at the systems in different ways. And there are different ways you poke at the system and analyze the system. And in climate, we've been using primarily simulations, and simulations are particularly bad at picking up the kind of complex system dynamics like abrupt change. And so it's particularly likely that we may be underestimating the kind of changes that we're facing. So we need to improve these badly, and we need to get more systems people using more different ways of looking at the system. And then experiments. So once you have the technology and you've done some modeling work, process-level studies of what happens when you release particles into the atmosphere, how they interact with the cloud, how they flow out into the stratosphere, those are really crucial. At very small scales, they can give you a lot of information to feed into models and estimate what's going to happen. So there are a couple of proposed experiments or experimental programs. This one is a picture of the program at Harvard, which is the most well-funded program in the world for looking at brightening the atmosphere. It's headed by a well-regarded, well-known scientist named David Keith. It's an interdisciplinary program that's been trying to look at the societal aspects of doing this as well. But they're proposing an experiment in the stratosphere using a balloon where they would release a number of different kinds of materials, only a liter each. So they'll be very lucky if they can measure what comes out. But they're looking to determine some of the initial chemistry of the interactions with those different kinds of materials in the stratosphere, and maybe something about the way they disperse. And that would be the first step in a very long sequence of studies, both in modeling and in experiments and in data, to try to get a grasp on whether this would work, what material you would want to use, and what kind of bounds you could put on the risks of it. So that program is happening. I don't believe they have a definitive date for that experiment, but I think they hope to do it sometime in the next year. And the University of Washington is the home of the program, which is not funded, and so consists of researchers working in their voluntary spare time, together with the engineers who've been working in their retirement. But what they hope to do is a sequence of steps that will go from generating a single plume over land, a plume over the ocean, and then finally a patch of ocean and clouds that they would brighten with multiple ships and try to measure changes in the reflectivity. And that whole sequence that they would like to do to measure changes in reflectivity of a patch of ocean and sky, which would be your first experiment in whether you can brighten a cloud, they think will take 8 to 10 years to do that sequence. I've pressed them on it. Like, well, if we have money, we can go faster. Okay. But to give you a sense, both of these experiments that I described are below the level where the EPA would even engage them for a review. So they don't contain physical risks with regard to the kinds of parameters that we have today for putting things into the atmosphere. But people are worried about them for other reasons, like the precedents that they might set or the societal forces they might set into motion.